I'm now going to hand over to my co-chairs to present. If you could present Professor Sultan.
Professor Sultan is with us? He's with us, okay. Now we'll introduce Professor Sultan. All of us know him already. He will give us lecture about non-compliant endograft for TEVAR, EVAR, or EVAR have a distributional effect on systolic, diastolic blood pressure and cardiac function. Best graft have not been designed, but a lot of lessons learned. Okay.
Mr. Chairman, ladies and gentlemen, I'd like to thank the committee for the kind invitation to present today. Non-compliant endograft for TEVAR and EVAR have determinate effect on systolic, diastolic blood pressure and cardiac function. Best grafts haven't been designed, but a lot of lessons learned. This is work done by myself and Juan Prodi over the past 8 years. Prosthetic aortic replacement causes aortic remolding with circumferential strain, which lead to progressive distal dilatation of the aorta with dissection and aneurysmal formation. All existing stent graft material decreases wall compliance with higher wall resistance. A systemic review and meta-analysis of 17 studies with more than 15,000 patients to evaluate aortic stiffness represented by aortic peak wave velocity as a surrogate endpoint for cardiovascular disease found that aortic stiffness is a strong predictor of future cardiovascular events and all-cause mortality. All of us currently doing now a 4D imaging. And the reason for that is to know exactly the dynamic. However, we haven't applied any 4D therapy where the 4-dimension is the time. We love to have instantaneous completion angiogram that looks great, but we don't know how far this could cause a problem with the patient. Currently, there's 4D MRA arterial compliance. We could do a 4D tissue function and virtual histology, but the therapy haven't matched the diagnostic power that we have. You remember in 2003, this paper from the Michael Marin group in New York, and talking about the mechanical failure of prosthetic human implants, and they represented to the FDA and showed that the average time to fatigue for all devices combined was 13 months with suture fracture, graft holes, or stent fractures. This metal fracture fabric erosion with ultimate device early fatigue failure was the result of these two components. Multinationals have moved to more durable graft at the expense of aortic compliance. So a knee-jerk reflex. They put this paper, went to the FDA got panicked, going to withdraw EVAR out of the market. So let's make the EVAR much more durable. By doing it much more durable, they make it a very stiff tube that create more havoc for the patient cardiovascular system. Just to go back a little bit of physiology, we know that the normal heart, there is a systole and diastole. And during diastole, the elastic recoil allows the filling of the coronaries. Then we went on and looking at a lot of patients who had an aortic transection. So their young patient came in trauma, and we put the best available graft on the market without any comparison is the Gore graft. Just, I don't work to Gore at all, but I'm just telling you. And we see this in comparison with any other graft, whether the Medtronic or the Cook. Definitely we done very badly from the cardiovascular, but it took them up to 2 years for this graft to produce a major cardiovascular problems. And what happened first, we find that there is wide pulse pressure. The systolic have systolic hypertension and the diastolic went down. And this wide pulse pressure have created the congestive cardiac failure that this patient later on have a problem. This is due to the loss of wing cell effect with alteration in pulse wave propagation result in adaptive left ventricular hypertrophy with loss of diastolic systematic augmentation with reduced organ perfusion, mainly myocardial ischemia, despite absence of coronary artery stenosis. TEVAR and EVAR alter timing of reflected wave with negative effect on left ventricular function. And this is the pre-EVAR wave, and this is the post-EVAR wave. And you can see that we have done a lot of computational modeling and analysis. TEVAR and EVAR patients have significantly higher post-operative peak wave velocity than those undergoing open aortic aneurysm repair due to loss of aortic wall wave propagation and plasticity, putting them at a higher risk of cardiovascular major adverse clinical event. Moreover, this work from the Francis Moll group, they found that preclinical and primary clinical studies report acute stiffness of aorta following TEVAR within 24 hours, resulting in acute elevated pulse pressure, hypertension, reduced coronary perfusion, and eventually heart failure within 24 hours. Remember that. Endovascular induced cardiac failure. We have done a huge amount of simulation and experimental evaluation of a device arterial wall compliance or computation fluid analysis of symptomatic chronic type B dissection or insight from the complex aortic surgery with a streamliner. And what we find, stent graft biomechanical properties are several orders of magnitude stiffer than the native aorta. Material that enhances durability, but it stiffens the aorta. Aortic compliance critical to reduce impedance and cardiac workload and aortic oscillation. TEVAR induces major adverse cardiovascular events. Patient developed AAA after TEVAR where infrarenal aorta weren't aneurysmal before TEVAR. And I'll show you a very strong examples about that. AAA development is a consequence of amplified aortic wall stress and activation of aortic cell molecular dysfunction. Polyester-based aortic endograft causes a threefold increase in peak wave velocity compared to PTFE-based platform. Rate of AAA development progression was alarming, with worsening hypertension and late cardiovascular major adverse clinical event. So this is a patient came to us in 2009, a little bit of a chest pain. We done a CT scan. We couldn't find anything. Wait a year. She came back with a thoracic aneurysm that was ruptured. So we put a TEVAR for her. And as you can see in here, we have to put a chimney to get a good ceiling. And this is the completion angio in 2011. There's nothing in the aorta. 2015, she came with a ruptured infrarenal aortic aneurysm that required a emergency EVAR. So this have led us to start thinking what's going on with these patients. And we published our experience in the European Heart Journal, where we have confirmed that combined thoracic endovascular aortic repair and endovascular aneurysm repair and the long-term consequences of altered cardiovascular hemodynamic on morbidity and mortality. Moreover, we have proven clinically and scientifically that TEVAR induces acute aortic stiffness. Medical device manufacturer must consider impact of graft stiffness mismatch, particularly with emerging role of TAVI and arch BVAR. So we're coming very closer to the heart, but we're putting more of a very stiff grafts. And all these cases about endovascular pentel and all this stuff, yeah, it looks great in the X-ray, but does the patient get benefit? Does the patient live more than a year? Does it improve the quality of life? No, they come in and they're starting having mayhem on their life. So all these patients we went on and we done a coronary angiogram, and believe it or not, all the coronary angiograms were totally normal. There is not one single disease. So the patient comes to you after the TEVAR or EVAR, you have chest pain, systolic hypertension, and you don't know what's going on. So an elevated troponin. We go in and we do a coronary angiogram. So they have a non-obstructive pattern of coronary artery disease because of the failure of the aorta for the elastic recoil and filling of the coronary artery. It's a major problem, and a lot of people don't understand it. And then the patient have systolic hypertension, the graft starts having to oscillate inside because of the very high blood pressure, and then the graft fail, and then we go for a mayhem of reconstruction and extracting the graft and doing a lot of very extensive surgery in order to save the patient's life. Aortic geometry, wall stiffness, blood pressure, and the longitudinal systolic aortic stretching and oscillation affect the peak wave velocity, contributing to biggest impact on wall stress. Computational model shows that all commercially available endovascular devices lower aortic wall compliance after implantation. So the whole idea here, we need to design a new graft. The whole idea is to prevent this wide pulse pressure, the congestive cardiac failure, and allow a graft that gives back the elastic recoil back to the aorta in order to fill the coronaries and prevent the cardiovascular problem. There are increasing evidence of adverse hemodynamic alteration post-EVAR and EVAR. Therefore, the best solution in the short term is to reduce the stented length of the aorta, while in the longer term, encourage continuous improvement in stent graft material and design. We have published about the contemporary abdominal aortic aneurysm device, 3 decades of research and development with big data. Why had the best graft not produced yet? It's a missed opportunity. And what we discovered that reducing profile of the delivery system to make technology more amenable to percutaneous access, thereby expanding customer base to other interventions. So the multinationals are interested to sell to the cardiologists, to the interventional radiologists, who cannot do a cut down. So they want to decrease the profile in order to sell more. In their pursuit of market share, they compromise fundamental science behind design of a good endograft and jeopardize long-term durability with negative cardiovascular consequences. Aorta is a functional organ which we should respect, preserve, and not eliminate. Regional aorta bioarchitecture varies considerably with implication for tissue function, and current devices lack compliance and induce cardiac dysfunction. Next generation devices must restore aortic compliance to reduce cardiac deaths. We know from our clinical experience that polyester-based endografts are implicated in development of post-operative pyrexia, which we call it post-implantation syndrome. All of you know about it, and everybody said, oh, there's no problem with it. No, wait. This PIS, or post-implantation syndrome, create acute liver or multi-organ failure and longer hospital stay post-EVAR and EVAR compared to the PTFE-based endograft. So you put a polyester-based versus a PTFE. Due to robust inflammatory response, so the people who have graft that have polyester base have huge robust inflammatory response, cause endothelial damage and increasing cardiovascular mortality. Polyester graft augment post-implantation syndrome with high interleukin 8 level, which act as a neutrophil chemoattracting that exert pro-tumoral function and plays role in tumor progression and metastasis. And we started putting that is because of too much CT scans. No, you are creating the problem and blaming the wrong guy on what's going on. So because of all of that, we went on and created the stage hyper single human reconstruction, or TIGER, in management of chronic symptomatic complex type B aortic disease, and then we start moving it to a lot of other pathology. So a lot of people come to, let's do petticoat, let's do stabilize, let's do flirt, FIVAR, BIVAR, candy block, knickerbocker. All this had increased cardiovascular mortality due to increase in arterial stiffness and left ventricular afterload with systolic hypertension. Decreasing the stent of the length of the aorta by TIGER protocol is the only existing solution until new advanced compliant graft become available for us. So basically, rather than doing a metallic jacket from the arch or ascending down to the common iliac, let's decrease the amount of that huge metallic trash with a lot of polyester in it in order to get a better outcome. So we started creating the smart endoprosthesis. It's a regularly expanding mesoporous silica nanoparticle as a nano carrier for a self-healing, self-repairing, and self-assembly system. We took this idea from NASA. When the spacecraft or the shuttle comes back to the Earth and start piercing the atmosphere, there's a lot of breaching in its external shell. This is automatically healed by an engineering RNA so that it's self-healing. We're going to apply the same idea to this. It is more robust and fault tolerant with transverse and longitudinal crimping that expand in systole and contract in diastole. This nanolite expandable layer of impervious silicone prevents tissue ingrowth, which averts stiffness and rigidity. This paradigm shift towards building smart endoprostheses that possess self-capabilities of advanced self-healing to repair themselves during the functional lifetime of endograft. Smart endoprostheses will lengthen product lifetime and abolish need of follow-up or re-intervention. It's like the Tesla-like scenario car. You don't need any sort of servicing because it's just go in electricity. Arterial stiffness after TEVAR and EVAR explain the dismal long-term outcome. Arterial stiffness should be taken into consideration by the industry when designing new endograft. Patients after TEVAR and EVAR are in need of intensive cardiac management. Mr. Chairman, ladies and gentlemen, we started thinking that EVAR is a solution. I start explanting a lot. And to this, I'm just telling you that it's back to the future scenario. We don't know where we are. Are we going to go EVAR or TEVAR, or are we going to go for open? Until we have a new technology that respects the aorta as an organ, we are playing with fire, and we haven't reached anywhere regarding giving a very good service for our patients. And thank you so much for the opportunity to present in this fantastic conference.
Sherif, this is fascinating.